Cool. Hi, folks. Thanks for joining us for what will probably be a little bit under an hour of discussion around AI agents. I'm John Dickerson. I'm Chief Scientist and co-founder of Arthur. We are a company in the observability and security space in artificial intelligence writ large. We watch over models that could be traditional models like, XGBoost or if statements or calling your grandma to ask what to do about a credit card application, or Gen AI-based applications like LLMs and multimodal models as well. This is not a pitch for Arthur, but if you're interested, obviously just go to arthur.ai or hit me up after the webinar. Cool. So many of you have probably heard in the news about AI agents, and I will come in here and talk to you about sort of what's new in this space, the history that led up to AI agents, and sort of what I see as the future, especially in 2025, moving forward. And had a lot of fun putting this deck together. It's very sort of hot off the presses. It's the first time I've given this. If you have any questions, if you have any comments, feel free to either type them into chat, or we can obviously have an active Q&A session toward the end of the webinar. Cool. So like I mentioned, these AI agents are all over the news right now. Okay, so these are largely press releases from the last, couple of months from startups. You see a lot of startups here like Crew AI, which raised a Series A in October, 11x, which raised a Series A actually in September, and then literally last night, as I was wrapping up this slide deck, announced a Series B just 2 months later, led by Andreessen. But also large companies like Salesforce, which has this agentic agent force that they've launched, I believe, a couple of months ago at Dreamforce, their annual conference. Coinbase, a large sort of centralized crypto wallet, launched an agent open source toolkit, which will allow you to use LLMs and other sort of AI related technologies to operate autonomously on the blockchain. I'm not making a normative judgment there, but the idea of using natural language to trade crypto is both terrifying and exciting. And then also, obviously, some of the largest companies like Microsoft, I'll cover a couple of their projects actually later in this webinar, have been putting a lot of effort into open sourcing and also operationalizing and commercializing agent-based and multi-agent-based systems that leverage some of their investments in large language models. So this is just like a random sort of covering of announcements in the space over the last couple of months. You can see that it's very, very active, though. Okay, so I would say like agentic AI is probably the #1 sort of buzzword in the venture capital and also in the large FANG style funding scene for AI right now. Cool. So there's a lot of buzz around this. I have my cute little bee that I generated using Gen AI. There's a lot of buzz around these agentic systems, right? And so I'd like to sort of get into what some of that buzz looks like and sort of maybe demystify what led us to this current paradigm. So here's the general agenda. I'll cover some actually basically like 50 plus years at this point of work that's gone into the definition of and composition of agentic systems. Agents, roughly speaking, are not new. I'll talk about what is new, though, right? So this is not going to be a curmudgeonly pessimistic talk. I'm actually very excited about the agentic sort of focus that AI has taken recently. So Gen AI-enabled agents are new. Okay, so this is not something that was really in the zeitgeist prior to certainly the ChatGPT launch in November 2022, so about 2 years ago at this point, but certainly not even like a year ago. Okay, so after covering the history of AI agents from a research point of view, I'll talk about what Gen AI companies mean when they talk about agents now, and I'll give you some advice about what to think about when deploying agentic AI writ large. And I do want to have a big disclaimer here, which is that this is a super new area, the Gen AI-based agent stuff, and so a lot of these are opinions, and I obviously might change those opinions in 3 months as we start to see these get more deployed. And finally, I'll leave you with some opinions, predictions about what's coming down the pipeline in this space. And I'll specifically focus on one thing I'm really excited about, which is taking agents, taking groups of agents, and then taking groups of agents and having them talk to each other. Okay, and so I know that feels a little far-fetched right now, but this is a prediction that I have for 2025. Cool. So again, feel free to drop Q&A in the chat, or I don't know if you can unmute your mics, but I'm happy to have this be very interactive, or we can just have a Q&A toward the end of the webinar. Great. So computational agents are very not new. Okay, I'm going to put on my professor hat for a little bit and give you a little bit of citations that led up to the current agentic revolution that's happening right now. Okay, so way back in the day, when computer science was not even really a real field at the time, so people who were thinking about computer science or artificial intelligence were coming from other forms of training, like psychology, cognitive psychology, especially economics, or what would then become behavioral economics, or other engineering disciplines, they've all been interested for a very long time in effectively creating computational clones of the human mind. Okay, so way back in 1960 even, this guy Herb Simon, who goes on to win Turing Awards, and he's a very famous person. He's one of the, I hate using the phrase godfathers of AI, but he's one of these big central figures in early artificial intelligence, stated that one of the models that was proposed by I believe, master's students of his, something called the Elementary Perceiver and Memorizer, or EPAM, would allow somebody with a computer to be able to create a model of the human mind. And I don't believe this, by the way, and I don't think anybody believes this at this point, but this is, 1960s is a long time ago. Probably a lot of us weren't born then. This was sort of the start of people really thinking about what are called cognitive architectures. Okay, so these are sort of like the psychology complement to what you can think of when you think about people thinking about AI agents right now. These are effectively theoretical structures of the human mind that also beget computational implementations of those theoretical structures. Okay, and I'm not going to dive deep into what these look like. Here's a really famous one, though, by a psychology professor at Carnegie Mellon University. I'm biased. I got my PhD there, but it's probably the leading AI institute in the world, and it has been for decades, basically. This is in 1973, something called ACTAR, the Adaptive Control of Thought, Rational, whatever, terrible name, was posited by this cognitive psychologist as a theoretical model of the human mind that could then be feasibly implemented as a computational process and then set off into the wild. Okay, so this is kind of like a proto-AI agent if you're defining AI to mean something like, I want AI to replicate human thought processes. And this kept trucking along. Another very famous architecture in this space is something called SOAR. It's now not an acronym, but roughly speaking, this came from state, operator, and result for SOAR. And this was led by a couple of folks, John Laird, and then another very famous quote-unquote godfather of AI, Alan Newell. Okay. And so, at this point, probably a lot of us on this call still haven't been born. But we have decades of research by very, very famous, very, very respected folks going into the use of cognitive psychology to provide theoretical frameworks of the human mind, and then thinking about basically creating computational implementations of these to try to mimic humanity. Cool. So why am I highlighting Newell and Simon, other than being very, very biased by my sort of CMU heritage here? Both were actually two of the, roughly speaking, 10 or so participants in what is called sort of the single workshop that kicked off the field of modern artificial intelligence. So this was held in 1956. So even before that 1960 EPAM thing I mentioned on the last slide, this was held in 1956 at Dartmouth, and it's called the Dartmouth Summer Research Project on AI. 10-ish permanent members there. You have a bunch of other folks who sort of floated in and floated out over the summer. Some names here that may be very familiar to folks. Claude Shannon, who is sort of the guy who invented information theory. John McCarthy, Marvin Minsky, John Nash, a big shot in sort of the game theory world. Arthur Samuel, and I have this highlighted in purple because that's one of the origin stories for the name of our company, actually, who arguably maybe invented the neural network. And this is broadly seen as the founding event for AI. Okay, so people who were thinking about agents were also the foundational folks who created this field to begin with. Okay, so it's not just that AI agents aren't new, it's that they are like a foundational part of artificial intelligence research going back now 70 years or something like that. And I love to look at quotes from this. You can actually look up the proposal to receive funding for this workshop that happened at Dartmouth in 1956. And there's some very, very optimistic language in there. Okay, so I'm just going to read this out loud. We want to find how to make machines use language. Great. Form abstractions and concepts, solve kinds of problems now reserved for humans, and improve themselves. That's a lot of stuff. Okay, so this is actually what a lot of the agentic, both commercialization and R&D that's happening right now is also positing to do. We think that a significant advance can be made in one or more of these problems if a carefully selected group of scientists work on it together for a summer. Okay, so a little spoiler there is that in the 12 weeks that these very smart people hung out at Dartmouth, they did not solve artificial intelligence, but they did actually lay the framework for a lot of the R&D that we're going to talk about today. Cool. So I do want to say this is not like one of those weird AGI seminars where I talk about AI, supplanting humans or becoming a human. All right, so going to push back on that, but I did want to give a little history on the cognitive psychology sort of backings for agentic AI research. Now, I want to now mention one of the very famous sort of technical books in this space, something called the AIMA, or the Artificial Intelligence: A Modern Approach series of books. The first of which I believe was published in 1995 by two very famous people as well. So Stuart Russell is a huge professor at I believe it's Berkeley, one of the two California schools, Berkeley, who's done a lot of very foundational work in this space. And then Peter Norvig is, I believe, head of research or chief scientist or some fancy title at Google, where he leads a lot of the AI research there. So these are big players in the space. They wrote a book that's had multiple editions over the years. First edition came out in 1995, and you can see up here in the right corner, it literally says the Intelligent Agent book. Okay, so this is like the standard AI textbook for an AI class. Machine learning probably uses something called the Bishop book or some more recent deep learning books. But if you have a course that's called AI, Artificial Intelligence, this is almost certainly the book that is either being considered or is being taught to. Okay, and so this is again 95. We're talking 30 years ago at this point. Literally cover this tome. The Intelligent Agent book is written. Okay, so going all the way back to 95, this is how these two big shots in AI define an agent. It's anything that can be viewed as perceiving its environment through sensors and acting upon that environment through actuators. Okay, so this kind of has a physical feel to it in that we're using sensors and actuators, but virtual agents as well will have some sort of perception of the world, right? They're going to go onto the internet and read a website. What does read a website mean? They're going to do some sort of signal processing from the raw HTML that flows in to understand what that website is about, right? Maybe they'll leverage embeddings or something like that. And they're going to act upon the environment using actuators. Well, it doesn't have to be some 6 degree of freedom, whatever, like a motor that's, having a little robot poke at a door or something like that. You can actually have actions that interact with a virtual environment as well, right? I, as an agent, can go online and make a post on Twitter, right? In that sense, I've interacted with the environment and I've changed the environment by taking an action. Okay, so this is roughly the classic definition of an agent. Very, very broad, right? I've already said it encompasses robots and encompasses virtual agents and so on, but it is sort of the agreed upon academic definition of what this is. Now, there's a definition of what I'll call a rational agent, right? So this is saying, hey, we have this little agent who's floating around in the environment. She's able to interact with the environment using actuators or other actions. Well, let's imbue some sort of goal, right? Let's imbue some sort of like what I don't know, ambition or purpose in this action, in this agent, and that's done through the incorporation of utility functions or cost functions, things from decision theory, and that's where this rational phrase comes from. Okay, so a rational agent, as defined by the AIMA, this sort of like classic AI tome, is an agent that acts so as to maximize the expected value of a performance measure based on past experience and knowledge. Okay, so it's going to be able to learn how to interact with an environment, and then it's going to, over time, be able to make those interactions be more efficient in some sense, right? Maybe there's a cost to taking actions, and it's going to minimize that cost such that it's able to achieve some goal very quickly, something like that. Okay, so there's an element of learning here. There's an element of interaction with the environment. There's an element of understanding where you are in the environment. And then there's this sort of element of like generalization, right? As I learn to interact with the environment, I can generalize that learning process to interact with sort of new situations that I find myself in. Now, this is the one I really like, and it really sort of brings home that message that this agentic AI stuff is not new and that it's core to AI. This is literally how they define AI research in that book. It's the study and design of rational agents. Okay, very short, very succinct, very clear sentence talking about AI is literally the study of agents. Great. So that brings us, roughly speaking, to where we are today. And again, I'll just say it one last time. If people have opinions or comments or whatever, feel free to drop it into chat. Great. So what's an AI agent? Well, if we look at like that AI, a modern approach to AI book, or if we look at any of the cognitive psychology work that came out of a lot of these sort of folks in the 60s, 70s, and 80s, you can roughly define not just agents, but artificial intelligence, literally the field that that we're talking about here, as roughly the ability to process and act based on information via automation. Okay, so that's roughly saying, hey, we need to develop some sort of in the modern days, it's going to be LLM or other sort of Gen AI based system that's able to perceive where it is in the world, understand the state of the world, learn from interactions with that world. Okay, so it's not going to come into either the virtual or the real environment, springing forth from Athena's head fully formed. It's going to have to learn to interact and basically act better over time. like I mentioned, it has to generalize. So that learning process is not just going to say, hey, today I was in this state and I took these actions and these good things happened. Tomorrow I'm guaranteed to be in that state again. So I'm just going to do the same thing over and over again. No, tomorrow you're going to be in a different state and you're going to have to try and take a set of actions that are going to do a good thing in that new state that you haven't been in before. So I need to have some sort of generalization here. And then the big one here, which is really going to differentiate what I might call agentic AI from traditional machine learning, traditional Gen AI, traditional LLMs, whatever sort of like buzzwords you want to think about, is this ability to reason, plan, and act. So sequential planning to get from where you are, whatever that might be, to a goal state, hopefully by minimizing a cost or maximizing a reward. Okay. And I have a couple like little footnotes here. This sort of set of 4 boxes is roughly how, for example, DARPA has defined AI agents over the decades. And it's a total aside here, but this is all public stuff on the internet. If you go online and you look at like DARPA presentations about different waves of artificial intelligence, DARPA right now thinks we're in the 3rd or the 4th wave of AI, and they'll light up different boxes to say what people are focusing on at that time. But this again goes back to like the 1960s and the 1980s and the 2000s and so on. So there are different advances and sort of different techniques that become in vogue in AI research over the decades, and they're all going to sort of like tackle different boxes here. I do want to say, I'm an optimist here, and I do think a lot of the agentic AI stuff that's happening right now really lights up all 4 of these boxes, which is pretty cool. It's pretty cool. We're definitely not solving AI, but like, it's a good time to be in this space for sure. So this is kind of a figure which describes what I said before, which is that AI, as defined as agents, right? As if we were to use Russell and Norvig's definition of AI literally just being the study of rational agents, is going to be sort of this superset of techniques, which includes all of machine learning. And all of machine learning is a subset, or is a superset of, for example, deep learning or Gen AI or LLMs or ChatGPT or whatever sort of buzzwords you're thinking about there. Okay, so AI is going to be strictly more general than machine learning, which is strictly more general than deep learning or Gen AI or techniques like this, which are addressing a specific subset of machine learning. Okay, so this is a very ambitious research agenda. It's a very ambitious commercial agenda for those startups that you saw that are moving into the space. But it's pretty cool that folks are pouring money into it, pouring talent into it, and I'm expecting to see a lot of advancements here. Maybe I have a question. Q&A. It's early in your talk, so maybe you'll cover it before you see my cue. But I'd love your views on whether agentic Gen AI will deliver real-world value in the area of RPA, where the system of record is a legacy old system. Yeah, thank you for that question. Not pronouncing your name correctly, Diarmuid. I do think that there will be value here, and actually you'll see in the projections that I have for 2025, literally the first projection is people starting to actually measure ROI, understanding that these systems are very expensive. But no, I mean, just anecdotally, when it comes to interacting with sales folks, right, or when it comes to interacting with developers or other sort of folks who have, as part of their day job, processes that are sort of rote and sort of like what you might call like legacy and a little bit like automatable. I see people rolling their own agentic systems right now that do these for them, and so that's not a statement about positive ROI necessarily. There could be cost to this, obviously. But I think there will be nuts that are cracked in that space that lead to real value for sure. We will get to that a lot more in sort of toward the tail end of the webinar, though. Yeah, great question. All right, so this is probably the most technical and nerdiest slide, and I promise it will get less technical after this, but I do want to basically couch my language in a technical definition of a rational agent. Okay, and I'm going to do this using sort of like the traditional like Agent 101 world, which is something called grid world. Okay, and I'll define this very, very, and this is in that AI book that I talked about. This is something that everyone who's taken like an AI class has worked in this space before. It's very toy. I know it's very toy, but hopefully it will sort of like drive home all these statements about perception of states and actions and reward and so on. Okay, so this very toy world has a little robot, and he lives in a grid. Okay, so he lives in a grid. In this case, it's a 3x4 grid. Okay, and we can index the states that our little robot lives in by indexing into these little grids. Okay, so 1,1 is his start state. From that start state, the robot can go north, or can go east, it can go south, it can go west to get to, for example, state 1, 2, or to get to, for example, state 2, 1. Okay. And so there are 12 potential states in this world, right? 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, and so on. 2, 2 is blocked off. You can't go into that, so maybe we can ignore that. And you see some other sort of states here as well. There's a pit at state, I guess, 4, 2. And if the robot goes into that pit, then he can't move anymore. Okay, so he dies. And he gets -1 reward. I'll define what that means. If the robot gets to state 4, 3, that's kind of the goal state, and he'll get +1 reward. Okay, so if I have a rational agent who lives in this state space, 1, 1, 1, 2, 1, 3, and so on, can take actions north, south, east, and west, which will, let's just say, move the robot in the way that you would expect, right? If it goes north, he can go north, or he'll hit a wall, or he'll fall into the pit, or whatever. There's a transition function, which is what I just defined there. I'm in a state, say 1, 1. I take the action north, and then I'm going to transition to state 1, 2 with probability 1. Okay, so in a dream world, I would have this function given to me, which roughly speaking tells me the dynamics of the underlying environment that my agent is operating in. I'm not going to have that in reality, obviously. There's a reward function, which is going to basically map, a state roughly to some sort of reward. So in this example, the reward for being in state 1, 1 is 0. The reward for being in state 1, 2 is 0. The reward for being in state 1, 3 is 0. And there are two sort of like distinguished states here. What you might call a sink state, or that pit, which is going to have a reward of -1. Robot doesn't like that. And a goal state, which is going to be 4, 3, which has that positive +1 reward, and the robot really likes that. Okay. Sometimes you're also going to have a couple other things. You'll hear these talked about in agent land from time to time. Something is called a discount rate. And so if you've been in finance before, you can roughly think about this as, well, if I get +1 reward today versus +1 reward a year from now, I'm going to value the +1 reward today as some greater fraction than the +1 reward a year from now, right? So this could be something like in health, your health is degrading over time. You want to be healthy today. You don't want to be healthy a year from now as much. I don't know, you value $1 literally today more than you would value $1 a year from now because of interest rates and so on. Okay, and so this sort of thing matters in that you're going to try to basically collapse reward accumulation into a shorter time frame. And then sometimes, I marked here that 1, 1 is the start state for the robot. Sometimes you don't really know where you start off. You just have a distribution of where that is. I think in most agentic AI scenarios, if you have, for example, a task that's given to you a priori, then you have a pretty good idea as to what you're starting off with. Okay. And then finally, you'll see, for example, these rewards that are mapped to different states. So here I have the reward for state 4, 2 is -1. The reward for state 4, 3 is +1. Okay. So I'm going to take a quick pause there. I realize this is a lot of notation. This is by far the most notation-heavy slide in this entire webinar. So if anybody has any comments here or any sort of questions, feel free to just bring them up. Oh, interesting. Another question here. So Darren asks, is there a wisdom of crowds opportunity with current LLMs who are poor at reasoning and planning? I'll get to that. So this is actually something called like multi-agent systems, or having like sets of agents who will quote unquote negotiate with each other or critique their own work and so on. There are frameworks that are starting to launch that really get at that. So yeah, hard to agree with that. In fact, I think there's a lot of value in like creating a diverse set of task-specific agents in the same way that there's that you mentioned the wisdom of the crowds, right? Like the entire idea behind that is different humans come into a population, they have different sort of expertise, and you're able to aggregate their information to create some sort of prediction. I think that same sort of thing can certainly happen with agents for sure. Yeah, great question. All right, so we got states, we got actions, we got dynamics for the environment, and then there's some sort of reward which says, hey, like if you get to a particular state, that's really good, or if you get to a particular state, that's really bad. So what are rational agents going to do now that I've defined this? Well, if we just have one agent, okay, so I'm not talking about sets of agents. This is just one little agent who's sitting around in this world who's trying to interact with the world in an optimal way. They're interested in finding some optimal plan, roughly speaking, a sequence of actions to get from where they are to where they want to be, where optimal is going to be defined as maximizing expected reward or minimizing expected cost, something like that. Okay. And so you'll hear these varyingly called different things. In the traditional agent research literature, these are called policies. So a policy is going to say, for any state, this is the action I should take, right? And these can be randomized or stochastic, you'll hear them called, but I'm just going to talk about the absolute base one here, which says, I'm in this state, I'm going to take this action, okay? So here we have a little graphic on the bottom right, which I took from a course at Berkeley, which has amazing graphics for that grid world, which gives you a policy for our little agent. So you can see, for example, if the agent is in state 1.1 down here, then the policy says go to state 1.2. So take action north and go to state 1.2. And then if you're in state 1.2, take action north again, go to state 1.3. If you're in 1.3, take action east and go to state 2.3, right? And so on, okay? So this actually looks like a probably the optimal policy for that world. Great. So that's the goal of an agent, is to find the optimal policy, often called pi star, which is going to map states to actions in such a way that you maximize expected reward. Cool. This is the TLDR for how to be a good agent, is wherever you are, you're given a task, you're sitting in the world, you have access to some information. If you just take the first step in the best way and then keep doing that forever, you're going to be optimal. Okay. And this is from a theoretical point of view, a very sort of like well-defined mathematical approach to designing and basically training and then deploying agents. But there are a lot of sort of caveats that might come into this, right? I made a ton of assumptions there on the last slide. For example, I said, hey, there are like 12 or 11 states, right? The state space in reality for a lot of agents, especially in modern Gen AI land, is astronomically huge. Like you can't write it down. A very, very basic state space could be, for example, launching an LLM-based agent from an initial sort of task description. And those task descriptions could be any potential set of 128,000 tokens that are passed into GPT-4o. Okay, so that's a huge state space. And that's not even taking into account things like the internet and your private data sets and all this other stuff. Okay, so that's enormous. I can't write it down. There's a huge problem with that. Your action space can also be huge, right? It's not just north, south, east, and west for my little robot in grid world. It could be, for example, choosing to visit any of the roughly 1.1 billion raw URLs that are available on the internet, or any of the 1.1 billion unread emails in your Gmail account, or whatever. Okay, so tons of actions that you can take from tons of states, right? The underlying environmental dynamics are also not going to be known. So if I want to try and compute this optimal policy, right, I need to be able to simulate offline, usually, the dynamics of the environment to be able to like learn a good policy. I don't know those, right? It could be like if I go on the internet and choose to tweet, right? I don't know how the world's going to respond to that. Or if I execute some code it's reaching out to emails or it's reaching out to my private data sets or whatever, I don't know what the result's going to be, right? And so there's a learning problem here as well, which is trying to understand sort of like how the world works as you actually interact with it, okay? And then finally, the world changes over time, right? So that transition function, the underlying environmental dynamics are not going to be fixed, right? So every day you're a financial firm, you upload new private documents to your private data store, and now your agent is going to have a larger set of actions, right? It can read different documents. The state of the world is going to change, right? I now know the ticker symbol for whatever stock you love has gone up or down or whatever. And so my reward signal is going to change, and just like everything is changing over time. And so even if I'm able to represent the state space, if I'm able to represent the action space, and I'm able to learn this transition function, it's going to age out very quickly. Okay. So these are the sort of modern problems that not just AI agents like what you hear in the news are handling right now, but also like robots, for example, right? Like autonomous cars, they also operate in this world where the state space is huge, the world is changing over time, and so on. So it's a really, really tough problem. And so the idea of finding a quote unquote optimal policy is it's pretty much unreasonable for a lot of these cases. So basically what you're going to do is you're going to try and do your best. Okay. And that, by the way, is just for a single agent. We had a question that came up, which was talking about multiple agents, the wisdom of the crowd. Obviously that's going to bring more power into the system, but also it's going to bring more sort of nuance into the way that you design and interact with the environment. There's a question here, what about inputs besides states? Yeah, Evelyn, I'm going to give you a couple of like concrete instantiations of what I might call an AI agent, the way that you're hearing about them in the news. So hopefully that will answer that question. So as I wrap up this sort of like background to AI agents, broadly speaking, if one were to solve this, right, if one were able to, for any sort of environment, find an optimal policy, then you're going to solve AI at that point, right? As defined by Russell and Norvig. It's a really general framework. It captures basically everything. It's strictly more general than traditional machine learning. Captures physical agents, captures virtual agents, captures all sorts of interactions between humans and AI and so on. A spoiler here, again, we haven't solved this yet, but we are making some progress on it, which is pretty cool. So moving forward, I'd like to talk about what enterprises and startups and VCs and the news and Twitter and whatever else are talking about when they talk about AI agents right now. Cool. So flash all the way back to 24 months ago. We were all naive, young, optimistic. ChatGPT launched, and our traditional sort of usage of ChatGPT was to send a prompt in and get some output. Okay. And that output was generated just sequentially, right? I'll pass in some sort of question, I don't know, what should I cook for dinner tonight? It's a set of tokens. It'll get magically embedded. It'll pass through ChatGPT, and ChatGPT will just spit out token after token after token after token to give me a response. Okay. There's no what people might call reasoning. There's no sort of iteration over different responses. There's no reflection on what has been generated before. It's just spitting out the next likely tokens. As the 2 years have passed on, there have been some bells and whistles that are added into these systems, right? So like if you were to use an OpenAI or an Anthropic or a Google product, now you'll have the ability to do what's called RAG, which is an ability to call out to a private sort of document store to retrieve information that wasn't included necessarily in the training of the underlying model. There's something called chain of thought, which you may have heard of, especially with the recent OpenAI launches of O1, which is kind of trying to break down a question into multiple digestible chunks to move forward. That's getting a little bit more toward the agentic style of reasoning. But roughly speaking, traditional LLM usage is just kind of this pass some info in, maybe augment it a little bit, and then just like spit out a sequence of tokens without thinking. Agentic workflows, right, are going to allow sequential planning or iteration and reiteration over different results, right? So it's going to say, hey, here's a task that came in. I'm going to try and intelligently in some way break that down into subtasks, and I'm going to try to complete a particular subtask. And maybe as I'm partially going through that subtask, I'm going to analyze where I am and how I feel I'm getting reward for figuring out that subtask. And I might backtrack a little bit and do a different thing, or maybe break down the subtask into other subtasks or something along those lines, right? So you can imagine sort of this iterative process where there's sort of what people are calling reflection or tool use, or calling out to get additional information and so on. And again, I'm going to say in the same way that like traditional LLM usage is what I would call like traditional machine learning, basically, you're just like inferencing through a model. This style of agentic workflow is going to be strictly more general. Okay, so flash back to that image I had of deep learning, machine learning, AI. This is taking you more toward AI, right? So it's going to encompass basically all that you could do with traditional LLMs and also more. There are some design patterns that are starting to emerge in this space. I'm taking these from Andrew Ng, who's another one of these huge figures in the AI world. He has like some great educational content on the internet as well, but I do roughly agree with sort of these design patterns that are coming out. One is reflection. Okay, so this is basically, and I realize I'm using sort of like agentic language here and viewing like agency on a model. I don't believe that LLMs are alive or anything like that, but just bear with me. It's much easier to speak this way. We're going to have a model or an LLM that basically looks back on its own work and says, hey, I didn't do a good job on that. I'm going to backtrack. I'm going to try it again. I'm going to do it a little bit different. I'm going to see if I do better this time. So it's not just a sequence that always goes forward. It's going to also think about things that I've done in the past and maybe redo them if I think I can do them better. Tool usage. This was sort of like the baby step toward agentic AI. Came out I don't know, a year and a half ago, something like that. And this is basically the idea that an LLM, while it's generating that sequence of tokens, can also generate a little token that says, hey, I don't know, generate some Python code that's going to do math for me, or call out to Wolfram Alpha to ask, how many kilograms a whale weighs, or whatever. Okay, so this is basically a single step usage of a tool that then returns a result that then goes into this generation of tokens that are happening at the raw LLM level. Okay, so this is very, very important. Multi-step planning is sort of the big dog here that I think really separates traditional LLM usage from what people are calling agentic AI. And this is the idea that I'm going to generate a multi-step plan to accomplish a task that hopefully minimizes costs or maximizes reward, right? And cost here might be some function of latency, how much money you're paying to Sam Altman for LLM calls, as well as, I don't know, maybe you're actually having to pay money to get access to private data. And then reward is going to be how satisfied you are with a particular result that comes out. Or, ideally you would connect that to some sort of downstream business KPI or some sort of ROI calculation that allows you to say, hey, I spent my money well. And then a design pattern that's starting to happen here, I haven't seen this actually sort of launched in the enterprise land yet, but it's going to happen at some point, is the use of specialized agents and sort of smart routing to say, hey, I'm going to have a really good math agent, I'm going to have a really good coding agent, and so on. For a math style task, I'm going to be able to route subtasks to a math specific agent that is maybe less costly than just using like a foundation model like GPT-4o or something like that. So I do want to give you an example that sort of backs up this slide that I'm just telling you, why would you trust me? Well, here's an example that basically backs this up entirely from one of the big open source vector databases. So these are folks from Weaviate who support what are basically vectorizing your private data and allowing you to search into that data to incorporate that into Gen AI enabled workflows. And they're saying the same thing here, right? So you see basically that in this, the lower framework here, they have an agent who's able to call out to memory. So it's able to have a scratch pad for thinking about stuff and also a long-term memory. It's able to do planning. They put reflection and self-critiquing into planning. I think that's probably right. And then it's able to use tools to call out to, for example, the public internet or a calculator or your mail or Slack or whatever. Okay. So all of this stuff is here from that last slide. I'm not the only one saying it. Andrew Ng's saying it. Weaviate's saying it. If you look up like what an agentic workflow looks like on the internet, this is roughly becoming what the reference architecture looks like. So as you're designing your own, this is roughly probably how you should start. Cool. So toward the question that was asked, I believe by, is it Evelyn? Yes, Evelyn asked about sort of an explicit, like what do inputs look like here? Well, here's a task that I might give to an agentic AI system. Write what's called an offering memorandum for my team's Series A. And so you can roughly think of this as like a quasi-financial document that convinces people, investors, people with money, to put money into a company or a team. Okay, so these happen for startups, these happen for private equity deals and so on. I don't know how to write one. I'm bad at math, I'm bad at finance and so on. So I would clearly ask a model to do this for me. An agent might generate the following plan. First, plan an outline for the document. Okay, so this is roughly speaking, I am given a task, write this offering memorandum, and the model says, hey, how do I accomplish that task? Well, first I break it into subtasks, roughly speaking, an outline. I might do some information gathering, right? I might use tool usage to call out to the web to get information about the company, company's competitors, the team. I might do RAG calls into private data to understand the company's financials, right? So I'm gathering additional information that's probably not incorporated into the raw LLM or set of LLMs that I'm actually using. I'll do a first draft of the memo. Why not, right? Like, let's just start spitting out some words. And then I might say, hey, I'm a memo writing agent. I'm really good at this, right? I've been trained on whatever, Goldman Sachs second-year analysts, interactions, and I'm really, really good at writing these memos. But I don't have a lot of experience actually making investor decisions. So I'm going to spin up some investor agent, right? And maybe that was trained or specialized on managing directors at Goldman Sachs who have done a lot of investments, right? And that's going to come in and it's going to virtually critique my investment memo, right? I'll get some feedback from it, and then maybe I'll revise that draft, right? And at that point, I might call out to a human, right? At some point, if you're going to actually put money into a company, unless you're Coinbase with agentic AI, which they released recently, which is trying to automate this entirely without a human, you're going to have a human come in and say, hey, thumbs up, thumbs down. Or maybe I'm going to call out to a more expensive investor agent or whatever, right? I might have this revision process, I might have this reflection process, and so on. Okay. So that's kind of a clear and I think very realistic use case for agentic AI, right? And I'm guessing that a lot of investment banks are actually developing things like this internally to really sort of supercharge their poor overworked analysts who are working 100 hours a week to put these things together. A couple of questions here. Is the prompt to plan step identical to chain of thought reasoning, or is there a difference? Chain of thought is getting a little bit closer to, great question, by the way, to long-term planning. But I would say when it comes to chain of thought, in raw chain of thought, there's not this element of backtracking. There's not this element of thinking like, hey, I'm going to take a step. I'm going to realize now that I took the wrong set of steps. And so I'm going to kind of move back into a previous state and take a different path forward. Okay, so you'll see obviously there's like tree of thought and a lot of additions to the chain of thought sort of paradigm of thinking that take it a little bit closer to planning. But raw chain of thought, I would say, is a subset of planning for sure. They're definitely related though. Second question. Found a research article that said after 10 competing agents is where you lose efficiently with WOC. Yeah, I mean, this is all going to be super task specific, super based on like whatever, budgets that you have and so on. Like there's no coming back. So to that question, there are all sorts of results in game theory land and in AI that say, thinking harder isn't always the right thing to do, even if you have an infinite budget. And that'll be the same thing with agents, right? Like at some point, there's going to be sort of a saturation of the amount of information you can aggregate from different negotiations across different task-specific agents. And it's just not going to be worth your while to add additional noise into whatever signal you're getting. So yeah, I don't know if I believe 10 as a magic number there, but yeah, I definitely believe in that curve. Yeah, great comment. Cool. So this is, by the way, this slide here, this is something that you could roll over a weekend, right? Or honestly, in like a single night. You could have an MVP for this style of agentic AI using open source tools like Nomic, like Weaviate, and so on. Open source models like Llama 3.2 or whatever. You could roll this very, very easily, and it would probably give you a little bit of value. Cool. So where did that plan come from, though, right? So let's go back to our little rational agent description from before, which said, hey, I want to have this optimal policy pi star that says for any input task, write a memorandum for my Series A, write a memorandum for my Series B, plan my vacation, talk to me about dinner, whatever, results in some sort of like plan, multi-step plan, tools, actions, etc., that gets me to my goal as quickly, as cheaply, and as well as possible. Obviously, all those caveats I talked about before still hold. And because you don't have the dynamics for the underlying environment and the state space is huge, the action space is huge, right? Actually learning this thing is super, super costly, right? And so we're starting to see some movement in this space. OpenAI's O1, I won't call it a model, it's like a system basically wrapped around a model, is starting to take steps in this direction, where they do what's called a heavy, and this is sort of outside the scope of this webinar, they do some what's called reinforcement learning to understand sort of the value of being in a particular state. They do that in like an offline mode, really, really expensive. And then when you're doing inferencing time, like online mode stuff, you're able to call out to this sort of value function that's learned for different states to do planning at inference time, right? There's a lot of exciting work in this direction. There's a paper that came out of, I think, Meta doing an open source implementation of this. But this is really like forefront of like what state of the art looks like right now, right? And it's definitely not a solved problem. Okay, so when you look at startups that are having these multi-step plans for their agents getting spit out, none of them are going to be even close to optimal, frankly. A lot of heuristics are going to be used here, a lot of domain expertise. There's going to be a lot of, basically fine-tuning, prompt engineering, all that kind of stuff that goes into these different vertical-specific companies that are launching agents. Yeah, so coming back to some other questions, like why stick to just one, right? Why not have a bunch, right? AI agents in general are going to make use of, their most basic form, a single large language model behind the scenes to do natural language understanding and so on. Why not like spin up a bunch of them, right? Why not have a specialized agent that's good at coding, good at math, good at speaking Spanish, whatever, and then intelligently route to those different agents based on what you think a task is going to be, okay? So a really simple instantiation of this would be to take an off-the-shelf open source model like a Llama 3.2 and then just prompt it differently. Say, hey, if I want to have a really speedy version of this agent, I'm going to say you are, you're really, really speedy at answering things. You don't care if you're really wrong. Just get a result back really fast. That's just a prompt to a raw model I haven't touched. Versus maybe I'll prompt it differently and say, hey, you're a really thoughtful agent. You only want to, stop thinking. Stop searching for more information when you're absolutely dead sure that your result is correct. Okay. And then if I have different styles of tasks, one is like, should I make an investment decision? That's going to go to the really sort of dedicated agent versus what should I cook for dinner? That's just going to go to some speedy result. I'm going to route accordingly. Where I think some value will be captured here is in the more involved versions of these, where you're actually going to fine tune or from scratch train the underlying models that empower these agents, not just doing prompt engineering, but actually touching the model itself to decrease latency, decrease cost, and increase sort of like task-specific behaviors and then intelligently route amongst those. And so I believe that like a lot of the startups in this space are moving in that direction as well. So here's a quick example of a multi-agent framework. This came out last week, 2 weeks ago, something like that, from Microsoft. It's something they call Magentic One. It's built on an open source toolkit, one of the first multi-agent toolkits that came out, actually, called AutoGen. You can just go online, you can clone these repos, you can run these on your own hardware if you want. And roughly speaking, we're going to have multiple agents. The first is going to be some sort of dedicated orchestrator agent. So that's going to be this this gray box at the top. And that's going to be some sort of like, the boss or the manager, if you will, who's going to take as input a task, and they're going to maintain knowledge that's learned from their fleet of employee agents, and they're going to basically assign tasks to a lower level of multiple agents who are specialized in particular ways, right? One might be very good at coding, one might be very good at understanding Reddit posts, one might be very good at understanding Stack Overflow posts, et cetera, et cetera, et cetera. And so that orchestrator is going to repeatedly call out to these task-specific underlying agents to receive new information. It's going to digest that new information to create new subtasks or say, hey, I learned enough. Here's my final response. The task is complete. Okay. So I think these are pretty cool approaches. To Microsoft's credit, they're very, very open about, hey, like this isn't solving everything. So if you actually just go onto their GitHub repo and you look at like, sorry, this isn't their GitHub repo. This is documentation for the site, but they're very, very upfront about this. They're basically saying, hey, like we don't know how to control these things. You look at number 1 here, right? Use containers. Basically sandbox off your little fleet of agents because they could go crazy and delete all your email or send text messages to your exes or whatever, things that you wouldn't want to do. Run them in a virtual environment, monitor them a lot. Don't let them run without a human looking at what they're doing. Don't pass data into them that you wouldn't want to, basically publicly go out on the internet and so on. So this is, literally from like last week. This is the state of the art in multi-agent systems. And there are tons and tons of risks around deploying these things. But there is also obviously a ton of power. Cool. So I guess in the last, I don't know, 5-10 minutes or so, I want to give a couple of predictions about what I see moving forward in 2025. I don't see agentic AI as a buzzword or as a focus moving outside of the zeitgeist. I do think it's going to be sort of the next powerful paradigm wrapped around large language models. And so I'm excited for the coming year. There's a lot to be done in the space, though. One is, and this came back to, I believe, the very first question that was asked about positive ROI. Cost really matters. These are not free systems to use. Even if you're running them on local hardware, time matters a lot. Cost matters as well. Electricity isn't free and so on. So at Arthur, we're hearing already tons of questions from the C-suite and product leaders, CFOs, CIOs, and so on, about basically measuring ROI on just even basic large language model-based applications, right? Like your basic baby's first chatbot or whatever. Roughly speaking, ChatGPT launches in 2022, right? End of 2022. 2023, a lot of budget was opened up for like demos internally that were using large language models and then more recently multimodal models to do what I would call like internal science projects and demos. This year in 2024, I'm giving this talk in November of 2024, we've seen a lot of these things go into production, right? So there are internal chatbots, internal RAG-based systems, and so on going into production at enterprises. They're getting monster usage, crazy token throughputs, lots of users. Everybody's using these things internally. 2025 is going to be the year that shareholders, if you're a public company, but your CFO and your CEO otherwise, are going to look at your wallet, basically. They're going to look at how much CapEx you're spending, like, oh my gosh, how much money are you just flowing directly to Sam Altman and Jensen Huang's pockets? Like, let's think about how much money we're spending and the actual ROI on these projects. Agentic AI is even more expensive than traditional LLM-based applications. You have tool usage, you have multi-step reasoning, you have offline reinforcement learning to understand how to do this planning, and so on and so on and so on. You have the orchestration layer for the multi-agent systems. There's a lot of power here. I'm super pumped about this, obviously, but it's super, super expensive. So one thing I think you're going to need to see in 2025 is understanding this Pareto frontier of cost, latency, risk, et cetera, versus using traditional ML, which is much better understood, I would say, than like Gen AI-based applications, versus simple LLM-based systems like what you might think about circa 2023, ChatGPT plus a RAG system, versus single agent versus multi-agent and so on. People really need to think about this, and I think this is going to be coming to a head in 2025. I think we're going to see systems of multi-agent systems, and this is probably like the most projecting into the future prediction. But basically, if we have individuals, I'm seeing in chat here that folks are talking about internal deployments that they already have of multi-agent systems, right? An individual uses AutoGen or Magentic One or whatever, or Crew AI, to launch their own little fleet of agents. Well, that fleet of agents it's not gonna interact in a vacuum with other employees at an individual firm. And so you're actually gonna have systems of people that have systems of agents, all interacting with each other, all costing money, all taking hardware, and so on. So understanding how to orchestrate these systems is gonna be very important as well. And so an example of this is literally yesterday, like 12 hours ago or something, 11x AI announced a raise just 2 months after their Series A. They took another $50 million, I think led by Andreessen Horowitz. And their entire pitch is basically enabling salespeople to use single or small double agent systems to enable lead generation. Now, obviously, these salespeople have their own incentives. They're interacting as part of a firm. Those leads aren't going to be generated in a vacuum, right? And so they're all interacting with each other at the firm level as well. And so understanding those interactions, I think, will be very important moving forward. And I'm really, really excited about this, right? Like I sound like a curmudgeon sometimes when I talk about technology, but in some sense, this is going to enable teams of humans who are enabled by teams of agents all to interact together, which I think is pretty cool. But tons of risks there as well, right? Lots of goodness, lots of costs, lots of risks. Another thing that we're starting to see is, even before sort of this agentic AI push, is the use of large language models to attempt to replicate human subjects in, for example, market research or in social science research. And I'm not going to go over all these different papers and so on, but these are all grabbed roughly from the last year or so. There are startups in this space that are basically replacing Mechanical Turk with large language models. There's academic research from computer scientists, psychologists, economists, and so on that's starting to appear saying, hey, we can replicate traditional social science results using large language models. There's promise here for sure. I do want to say that we have an open counter argument to this, which talks about some of the risks in this space. Feel free to scan that QR code and look at this, basically saying, hey, you can't just do a drop-in LLM replacement for humans. Like, sorry, folks. But there's value in doing this, but like, don't just assume that you can replace a human with an LLM or with an agent. That said, literally yesterday, Microsoft released a different multi-agent system, something called TinyTroop. Cool idea. But the entire top-line pitch for this is that it's an LLM-powered multi-agent persona simulation for imagination enhancement and business insights. Okay, that's word for word verbatim, just copied from their repo. And these are the use cases that they talk about for this simulation. One is to literally simulate an audience for marketing materials prior to buying ad creatives. Another is to simulate focus groups to give product feedback prior to making a product decision. Okay, and so these are explicitly saying we want to, instead of having humans be, a focus group, we want to have LLMs do that, or agentic AI do that. So I think 2025, you're going to see a lot of good things happening in the space. I think you're going to see a lot of bad things happening as well. So I'll leave this with a kind of summary here. So what's old is definitely new again. Like I mentioned, the thoughts around agentic AI are definitely not new. They started being thought about prior to most of us being alive in, let's say, 1956, the birth of AI. This is the story of AI, though. This is just what happens, right? Like AI ideas get proposed and they don't work because of hardware issues or software issues or data issues or whatever. And then 20 years later, they start working and then they stop working again and they start working and so on. That's fine. That's science. That's the way the field works, right? And so I have this little figure here. If you've ever heard of like AI winters and AI summers, which is like this sort of like cycle of funding and hype around AI. Totally fine. This time it works. I kind of agree, actually. Like this time, a lot of the agentic AI stuff is pretty cool. It's pretty democratized. You can use it. You can spin it up in a weekend. I am a curmudgeon. That's just who I am. But I'm super excited about this. I think there's a lot of value in combining planning and reasoning with present day LLMs, which are already incredible, frankly. That said, in 2025, just a caution, there will be a ton of snake oil being sold here. There is so much money at the VC, the PE, and the FANG level flowing into agentic AI right now that there will just be a lot of, frankly, BS that comes out. So understand what your firm needs, understand that Pareto frontier cost-benefit analyses, understand if you even need to be using such a powerful tool like an agentic system, understand risk measurement, and then mitigation techniques, because these things are very nascent, they will screw up. All of this will be necessary if you want to identify sort of like the diamond in the rough cases for these systems. And they will be there. There's a lot of power in this, but not everything that you read about on the news is going to come true. So with that, I will happily take questions, and thanks for popping by. Oh, lots of questions. One is saying that they use a multi-agent architecture in 2 different projects. One has 15 agents and another has 41 agents. We found the orchestrator versus lower level to be effective. Yeah, that's kind of like the reference framework that I'm seeing come into play with multi-agent systems. You'll have like one sort of top level agent, basically, who's doing the task assignment and sort of the management of multiple lower level agents. And it's a very natural framework, I think. Jeff says, Salesforce came out with Agentforce, which is similar to a system of agents like this. But Agentforce is really a comprehensive AI ecosystem. Salesforce has advanced autonomy and reasons with its Atlas reasoning engine. That's a lot of very Salesforce-specific language. I'm not super familiar with Salesforce technology. I don't think anyone is really differentiated in this space in a real way, though. I think most of these multi-agent systems are, to the last question, a single orchestrator and a bunch of sort of task-specific agents. I don't see any reason why Salesforce would be like super differentiated there yet. Cost is an issue. It took us 2 months to drop the price from $3 to 30 cents per run. Yeah, so this is an interesting point about LLMs in general, is there really has been, there's a lot of competition in this space. So if you look at like token pricing has dropped precipitously over the last couple of years. And, as people understand how to host fleets of agents more efficiently, it's not the same as hosting a large language model necessarily. Like the interactions are very different, parallelization looks very different. I think you will see cost dropping a bit. But coming back to that chart that I showed earlier, these are strictly more general than machine learning. And so I think they're going to be expensive systems no matter what. And that's not just cost, again, right? You're now calling out to like data sources and running code and all sorts of things that will also take a lot of time to give you responses. Darren, agentic solutions are expensive, but do they have to run more than once if they're code factories? They can generate software programs. Yes. Okay, I think I understand the question. So the idea is if I give you a task, I have an agentic workflow put together code, like raw code, like deterministic code, for example, or deterministic code plus a model, something like that, that will then solve that task moving forward. Yeah, but I think making that code generalizable to other tasks, right? If you're going to ask a new task tomorrow, is more difficult. So if you have the same exact task every single day, for example, whatever, check Google Finance and get like Palantir's stock symbol and price or whatever, you can create code for that and then run that for sure. But if you want something more generalizable, I think it's a little bit more difficult. Thomas says, given LLM outputs aren't deterministic for enterprise processes that require certainty, the task has been done correctly before moving to the next step. How do you see systems of AI agents accounting for that and solving that problem? Yeah, I mean, this is a tricky problem, and it's one that has existed since before sort of the LLM or Gen AI revolution, right? So machine learning models are typically stochastic, right? If I ask, even like a random forest or something like that, if I don't set a random seed and I ask a prediction 3 times in a row, I might get 3 different answers. And so this has always been an issue. It's certainly an issue when it comes to Gen AI, which is, say, even more stochastic because it's not well-defined or whatever, but like they're very stochastic systems. And then obviously with agents who are interacting with a dynamic world and maybe other agents, maybe other strategic agents not owned by you, you're going to get very different results coming out. Yeah, I mean, this is really a question about governance and risk. And I think every enterprise is going to have a different appetite for that. But the idea that you can get deterministic results out of this is, I think in many cases, not possible, right? Because you're calling out to the internet or emails or whatever. That's changing over time. Evelyn says, are traditional forward and backward chaining tools used? Are we talking about, maybe I'm not backward chaining? I'm blanking on what that is. Maybe Evelyn, can you clarify what you mean by that? And Liliana says, is language a barrier for the availability for agent-based solutions in any specific context? For example, Spanish-speaking countries. This is an interesting question as well. So it's not specific to agentic AI either, right? So like large language models are, roughly speaking, only as good as the data that they're trained on. And if you believe that large language models are primarily trained on data from the internet has a lot of English on it, right? It has actually a lot of Spanish too. So to your point, I think Spanish is probably pretty well represented. But if you start going toward like less spoken languages, right? For example, I'm giving this talk out of Seattle. There are a lot of Native American communities here that speak languages that probably are not very well represented in the training corpora for these large language models. That will certainly be an issue when interacting with these systems for sure. But no, I mean, when it comes to like English, Chinese, Spanish, French, etc., these are pretty well represented at this point and are pretty good. Oh, Evelyn said, oh yeah, I see. Forward and back yeah. So languages like Prolog or Ops5 and so on. Yeah. So the broader question here is, are we incorporating tools from traditional like logic programming or symbolic reasoning into agentic AI systems? Two responses there. One is I'm very excited about that because a lot of the initial planning work in research land comes from sort of like very formal, verifiable plans that can be created and then verified and so on. There are all sorts of issues with this, like representing, for example, the space of all plans using formal logic can be very, very large. It's very hard to do. But it also gives you a sort of like concreteness to what's coming out of these systems. And so there is burgeoning research trying to connect these two. You run into some issues for sure. All of these traditional AI issues, like representational problems, it's also very, very hard, obviously, to like differentiate through symbolic systems versus pick your favorite transformer or whatever. But there's a lot of cool work in this space moving forward. I haven't seen it in deployment yet, though. Yeah, great question. Lovely. I don't see any other questions. But goes without saying, thank you for popping by. I'm really excited about the coming year. And if you have any questions, feel free to just hit me up. I'm just John, John, @arthur.ai, or